In this video, we're going to do an overview of the quadratic equations and see what's going on. In our previous unit, a little while back, we talked about exponential equations where we had y equals a b to the power of x. Now our kind of base or simplest quadratic equation is going to be y equals x squared. And we're going to add some other letters in here and build slightly more complicated graphs, but for now, let's just talk about y equals x squared. We've talked before, there are different ways of representing relationships. This is our equation. This is one way of describing the relationship between the x and the y. Another way is with a table of values. So let's make a table of values to represent this relationship. As always, remember x is my independent variable, so I can just choose some values for x. Let's choose -2, -1, 0, 1, and 2. And I want to find the matching y values. So you should be familiar with this idea now. We're going to take our equation, we're going to calculate our y value by plugging in the number we've chosen for x. So instead of x squared, I'm going to do -2 squared. -2 times -2, you can do it in your head or you can use a calculator, is 4. Next, to find my y value, it's x squared. So x is -1. So when x is -1, y is -1 times -1, which is +1. Next, 0 squared is 0. Next, 1 squared is 1. Next, 2 squared is 4, and so on. So this is our table of values. Let's make a quick graph and see what that looks like. So we've used our equation. We've used that to find our table of values. And now we're going to find our graph. So I'm going to sketch that very quickly. My x values go from -2 to 2. So 1 and 2 and -1 and -2. My y values go up to 4 and no negative, just +4. So 4 and 2 and 3 and 1. I'm not going to label just to save space. Let's plot our points. When x is -2, y is 4. So x is -2, y is 4. -1 and 1. When x is -1, y is 1. 0 and 0. When x is 1, y is 1. When x is 2, y is 4. You might already have noticed something about the shape, and that's that it's symmetrical across the y-axis. So if I just drew half of it and then held up a mirror, it would look the same. I might actually have a mirror. Let me see if I can find that to demonstrate real quick. All right, it's not perfect, but we can kind of see that if I have the reflection here, I get my nice smooth curve going all the way through. Same as if I remove the mirror. This shape is called a parabola. So we're talking about quadratics, we're talking all about parabolas. And parabolas always have a symmetry where the left side and the right side look the same, just flipped. There's also a feature here, this point here, it's called the vertex. And we can think of that as the tip of our parabola. So if it was a little point here, it would be like the head of the arrow. Parabolas have a rounder shape like this, but it's still the equivalent point. So this is called our vertex. Finally, if I give you something like this, how do we know for sure that it's a quadratic equation? Well, if I have an x to the power of 2, if the exponent is 2, then it's quadratic. We can also look at the shape, but notice if I only gave you this part of the graph, this looks very similar to an exponential curve. It's hard to tell just by looking at it. So there's a test we can do, and let's take a look at that test. So this is our quadratic test. So remember, we've done a linear test before, where I looked at the first difference, and if the first difference is the same, then it's linear. We've done our common ratio test for exponential functions or exponential relationships, where if the common ratio or first quotient was the same, then we knew it was exponential. In this case, we're going to check for our second difference, and if our second difference is the same, then we know it's quadratic. So let's take a look. We're going to find our first difference just like we did before for linear functions. We're going to take a y value and subtract the one that came before. Please be careful. Students flip this around all the time. They're doing like 4 minus 1 and 1 minus 0. No. Subtract the y value from the one that came before it. So our first difference is 1 minus 4. which is -3. Our next first difference, 0 minus 1 is -1. Our next first difference, 1 minus 0 is 1. And 4 minus 1 is 3. All right, these are not the same. That's fine. This is our first difference test. That just means it's not linear. Now we'll do our second difference test. And we're going to just follow the same pattern, but we're going to find the differences of our first differences. So let's take a look. -1 minus -3, which is the same as -1 plus 3, is 2. 1 minus -1, which is the same as 1 plus 1, is 2. And 3 minus 1 is 2. Therefore, this relationship is quadratic because second differences are all the same. All right, so that is your quick crash course into quadratic equations. The different ways of representing them, the equation, the table of values, and the graph. A couple key terms. This shape is called a parabola, and this point on the graph is called the vertex. And how do we prove if it's quadratic? We do our second difference test, where I find the first difference, like my linear test. I take those numbers and find the next difference, called the second difference. And because they're all the same, we've confirmed that this is quadratic.